The instruction was not to board up the windows. It was not to move to higher ground. It was to get into the caves. That's what went out to the handful of people known to be on 3 volcanic islands in the far northern Pacific on Saturday night. Stay inside the shelters, stay inside the caves, and do not come out until somebody tells you it's over. Not a metaphor, not a dramatic flourish from a newsroom. That was the wording in the official statement from the National Weather Service, and it went out because a storm that had been an unimpressive, lopsided mess of clouds 36 hours earlier had turned into something with an eye you could see from space. Its name is Sodle. It's the 18th named typhoon of this Pacific season. And in the 24 hours leading up to Saturday morning, it went from 69 miles per hour to 109 miles per hour, which is the meteorological equivalent of a car pulling onto a highway and hitting triple digits before it finishes the on-ramp. I want to walk you through exactly what happened out there, because this storm did something that forecasters have a specific technical name for, and they don't hand that name out casually. I also want to show you the part almost nobody is covering yet, the 3-day countdown that's now running toward Okinawa, and the moment after Okinawa where the forecast splits 3 ways between 3 different countries. If you follow real Earth events with real numbers attached, this channel tracks them the day they happen, and subscribing means you get the next update in this story rather than finding out about it a week late. So let's start with what's confirmed. At 6 in the morning Coordinated Universal Time on August 22nd, the Joint Typhoon Warning Center put Saudel at 109 miles per hour sustained with a central pressure of 963 hectopascals. 24 hours before that, the same storm was carrying about 69 miles per hour. That's a jump of roughly 40 miles per hour in a single day, and it crosses the formal threshold that forecasters call rapid intensification. It isn't a vibe, it's a defined, measurable event, and Sodle met it. By the evening, the center was passing about 30 miles northwest of Agrihan, 65 miles north-northwest of Pagan, and 100 miles north-northwest of Alamagan. It was crawling northwest at 10 miles per hour, slower than most people jog. Typhoon force winds reached out about 45 miles from the middle. Tropical storm force winds stretched 150 miles, so even though the very worst of it stayed offshore, the islands underneath got hours of it rather than minutes. The forecast for those 3 specks of land was 80 to 100 miles per hour of sustained wind, with gusts up to 130, rain totals of 8 to 12 inches by August 23rd, with the possibility of more than 20 inches somewhere near the core, most likely over open water. Coastal flooding of 1 to 3 feet around Agrihan and Pagan, life-threatening surf pounding the reefs on the south and east faces, expected to keep going into the following day. And here's the number that stops you. Out near the center of that storm, the significant wave height was running around 34 feet. Later estimates pushed toward 38. That's not a wave you ride out. That's a moving 3-story building made of seawater. And there were hundreds of them, arriving one after another, all night. Meanwhile, further south, Saipan and Tinian caught a break. They were placed under an all-clear by 8 in the morning local time. The ports reopened to commercial traffic and cargo a little after 6:30 that same morning. The tropical storm threat to those 2 islands ended, though the seas and surf stayed hazardous because the ocean doesn't get the all clear at the same time the sky does. Now let me show you the picture that told forecasters everything. On satellite, Sodle had punched open an eye about 23 miles across. Think about that for a second. In ordinary terms, a circle of relative calm wide enough to swallow a mid-sized city whole, ringed by the most violent weather on the planet, sitting in the middle of an ocean where nobody lives. Around it, deep convection wrapped most of the center. The analysts logged high confidence in where the storm was, medium confidence in how strong it was, which is normal because out there, thousands of miles from the nearest weather radar, intensity is read from satellite signatures and mathematics, not from an instrument sitting in the wind. The Japan Meteorological Agency measured it at 960 hectopascals with sustained winds of 90 miles per hour. And if you're wondering why one agency said 109 and the other said 90 for the same storm at almost the same moment, that isn't a contradiction, and it isn't anybody being wrong. The American Center averages wind over 1 minute, the Japanese agency averages over 10, a 10-minute average smooths out the fiercest gusts, so it always lands lower. Same storm, two rulers. This one detail causes more online arguing about typhoons than anything else, and now you'll never be confused by it again. Here's the part where I'm going to be straight with you, because it matters more than the drama. You are going to see this storm packaged elsewhere as a catastrophe that flattened inhabited islands. It didn't. Agrihan, Pagan, and Alamagan are among the emptiest places in the entire Pacific. Pagan was largely abandoned after a volcanic eruption in the 1980s. Agrihan holds the highest peak in the whole Mariana chain, and its population has swung between a few dozen and almost nobody depending on the decade. When the Weather Service issued its warnings, the language used was about the few people known to be on the Northern Islands. That's the honest scale of it. There is no mass casualty story here. No city underwater, and anyone selling you one is selling you something. What makes Saudel worth 20 minutes of your attention isn't a body count, it's the mechanism, because the way this storm grew is the same way the truly monstrous ones grow, and it just happened in front of us with every variable measured and logged. This was a live demonstration of the machinery, and the machine is now pointed at somewhere that very much does have people on it. So how does a lopsided blob become a buzzsaw in a day? 3 ingredients had to line up, and all 3 did at once. The first is water temperature. The sea beneath Sodle was sitting between 86 and 88 degrees Fahrenheit. That's warmer than most heated swimming pools. Warm water evaporates, that vapor rises, and when it condenses higher up, it dumps heat into the storm's core heat that becomes wind. Warm sea surface is the fuel line. But surface warmth alone is a thin story, and this is where most explanations stop short. A hurricane is a giant mixer. It churns the ocean beneath it and drags colder water up from below. If the warm layer is shallow, the storm essentially spends its own fuel supply into extinction, chilling the water underneath itself until the engine coughs. Think of it as the difference between a thin wallet and a deep vault. A thin warm layer is a wallet impressive for an hour, empty by morning. What Sodle found east of the Marianas was a vault. Deep, high ocean heat content, warm far enough down that the churning couldn't reach cold water. It could spend all night and never run out. The second ingredient is wind shear, and shear is the thing that kills more would-be monsters than anything else. Shear is the change in wind speed and direction as you go up through the atmosphere. A cyclone needs to stand up straight, a vertical column stacked cleanly from ocean to stratosphere. Strong shear leans that column over and tears the top off it, and the storm bleeds out its heat sideways instead of concentrating it. Sodle's shear was running around 6 to 12 miles per hour. That's slower than a bicycle rolling down a quiet street. Nothing was pushing on it. Nothing was leaning it over. It got to stand perfectly upright and build. The third ingredient is outflow, and outflow is the one nobody talks about. Air rushes in at the bottom of the storm, rises through the towers of thunderstorm around the eye, and then it has to go somewhere at the top. If it can't escape, it backs up, and the whole system chokes on its own exhaust. Sodle had strong poleward outflow, a wide-open escape route running north at high altitude. Fuel line open, column standing straight, exhaust vented. Every single thing this storm needed, it had at the same time over the deepest warm water in that part of the ocean. That's why the intensity forecast for it kept getting rewritten upward. The center noted that multiple rapid intensification aids had triggered at once, and it deliberately placed its official forecast on the aggressive end of what the models were showing, rather than in the safe middle. That's a quiet but revealing decision. Forecasters don't lean high for fun. They lean high when the satellite is showing them something the average of the models hasn't caught up to yet. And this stretch of ocean has a history of doing exactly this to storms. Go back to 1965. A typhoon named Carmen rapidly intensified into a super typhoon in almost precisely this neighborhood, right around Agrihan, and its center passed directly over Pagan, where winds around 170 miles per hour were recorded. It destroyed buildings and crops on Agrihan. Go forward to 2009, and a typhoon named Choi Wan did the same thing, a rapid climb right through the Northern Marianas, reaching some of the highest wind estimates of that entire season. There's another echo in this storm's own name. Sodel comes from the Pohnpeian language, where it refers to a trusted guard serving the Sodeler chiefs. It's on the list because the name that used to sit in that slot was retired. That earlier storm, Sodle, tore through Taiwan and mainland China in 2015, killed dozens of people, and caused billions of dollars in damage. Names get retired from rotation when a storm is destructive enough that reusing it would be indecent. So this typhoon is, in a literal administrative sense, wearing the replacement badge of a storm nobody wanted to name again. I'll admit that when I lined those three storms up on a map 61 years apart, same patch of water, same behavior, it did stop me for a moment. Not because it means anything mystical. It doesn't. It's just that some pieces of ocean are shaped by depth and current and latitude to do a particular thing to whatever drifts across them. And this one is shaped to make typhoons dangerous. Quick question for you while we're here, because I read these. If you've ever been through a typhoon or a hurricane actually inside one, not watching it on a screen, drop the storm's name and where you were in the comments. The stories under these videos are consistently better than anything I could write. Now let's talk about where Sodle is going, because this is the part that actually has stakes attached. As of the most recent tracking, Sodle was roughly 1,180 miles east-southeast of Kadena Air Base on Okinawa, moving northwest at about 16 miles per hour. It's riding along the southwestern edge of a subtropical ridge, a big dome of high pressure sitting to its northeast. Storms don't choose their path. They're carried, like a leaf on a current, by whatever large-scale pressure pattern surrounds them, and the edge of a ridge acts like a guide rail. Over the next couple of days, that ridge is forecast to merge with a second ridge positioned over southern Japan, two guide rails becoming one longer guide rail, holding Sodle on a west-northwest heading. That's why the timing toward Okinawa has stayed so consistent across forecast cycles. The steering isn't ambiguous yet. Here's the schedule the agencies are working with. Peak intensity is forecast for around 1800 Coordinated Universal Time on August 23rd, holding into the morning of August 24th. The American Center's number for that peak is about 150 miles per hour. The Japanese agency's forecast for the same window is a central pressure near 925 hectopascals with sustained winds of 112 miles per hour on its 10-minute scale, and it uses the word violent, which, again, is a formal classification tier in the Japanese system, their highest, not a bit of newsroom vocabulary. Then comes the turn toward the Ryukyu Islands. Both agencies have Sodle near Okinawa around 6 in the morning Coordinated Universal Time on August 26th. The Japanese forecast center point sits at roughly 25.9 degrees north, 127.7 degrees east, which is right on Okinawa's doorstep. The American forecast has it arriving there with winds near 104 miles per hour. Notice something about that number. 150 at peak, 104 at Okinawa. Sodle is expected to be weakening when it gets there, and that's not wishful thinking. It's physics with a reason attached. After about 36 hours, that poleward outflow channel, the exhaust pipe, is forecast to weaken, and northwesterly shear is forecast to increase. The column starts getting leaned on again. Then, if it pushes into the East China Sea, it runs into more shear plus dry air being fed in by a strong ridge over eastern China. Dry air in a tropical cyclone is like water in a fuel tank. It doesn't stop the engine instantly, it just stops it from running clean. But a weakening typhoon is not a harmless typhoon, and I want to be precise about that. Okinawa has already been through this once this month. A typhoon named Dolphin strengthened near Okinawa in early August, injured people there, and then went on to make landfall in mainland China, where 5 separate stations broke their daily rainfall records. Ground that's already been saturated once handles the next storm worse, not better. The second punch always lands on a bruise. And then there's the question that makes this a story for 3 countries instead of 1. After Okinawa and Amami Oshima, the forecast stops being confident. The Japanese forecasters have said this plainly. The track after the typhoon passes those islands remains highly uncertain. It could continue west toward the eastern coast of China, it could bend north toward the Korean Peninsula, or it could curve southwest toward Taiwan. Those aren't shades of the same outcome. Those are 3 different nations, 3 different sets of evacuations, 3 completely different weeks. The reason the forecast falls apart there is the ridge. Right now, the steering is clean and everyone's models agree. Beyond about 3 days, the dominant steering influence is expected to hand off to a different subtropical ridge sitting over eastern China, and the exact position and strength of that ridge is what decides which of the 3 doors Sodel walks through. A small error in the ridge becomes a huge error in the storm's destination, the same way a tiny change in the angle of a thrown ball becomes a very large change in where it lands. You can watch that uncertainty growing in the actual numbers, which I find far more useful than any adjective. Through the first 72 hours, the spread across the models, the sideways disagreement about where the center will be, is around 144 miles. Beyond that, it widens toward 196 miles. And other analyses put the 3-day spread near 184 miles, growing to about 230. The confidence rating drops from high to medium at exactly the same point. The models themselves are split in a specific way that's worth knowing. The European model and the American global model both want to make a faster southwestward turn. 2 newer artificial intelligence-based forecast systems want to hold the storm further along. And 1 older model, an outlier, wants to send it dramatically further south than everyone else, which forecasters are largely discounting. Because when a single model disagrees with every other model, the smart money says the model is wrong, not the world. The intensity forecast has a split running through it too, and it's a wide one. The specialized rapid intensification tools are suggesting Saudel could peak somewhere between 161 and 173 miles per hour. The more conventional guidance tops out around 121 to 127. That is a genuinely enormous gap, the difference between a serious typhoon and one of the strongest storms on Earth this year. The official forecast, at about 150, sits closer to the aggressive end. So even the professionals are openly saying, we know it's climbing, and we don't yet know where it stops. Now, the hazard everybody gets wrong. When a typhoon approaches, coverage fixates on wind speed, because wind speed is one number and it fits in a headline. But across the Marianas right now, forecasters have been pointing at water, not wind, as the real threat, and that's the pattern in tropical cyclones almost everywhere. Water kills more people than wind does. It always has. And there's a second act coming that nobody's watching. Behind Sodle, a separate disturbance northwest of Yap is being tracked, combined with a surge of southwest monsoon moisture. That combination is forecast to push locally heavy rain from Guam northward to Rota. There's a hydrologic outlook on the table calling for 4 to 7 inches of rain across Guam, Rota, Tinian, and Saipan starting around August 25th, with rising flooding and mudslide potential. Sit with that sequence for a moment. The islands take days of typhoon swell and rain. The ground and the drainage systems soak it up. The storm leaves. Everyone exhales. And then, 72 hours later, a completely separate system parks over the same saturated hillsides and dumps another half a foot of water onto slopes that have nothing left to absorb it. That's how landslides happen. Not during the famous storm. 3 days after it, during the one nobody named. So what does any of this mean if you're one of the people in the path rather than one of us watching from a screen? If you're on Okinawa or Amami Oshima, your useful window is right now, in the calm days before it arrives, not on the morning it does. Secure anything outside that can become a projectile, because at 100 miles per hour, a plastic chair stops being furniture and becomes ammunition. Assume power and water interruptions and prepare for several days, not one. Charge everything. Fill containers. Know whether your building or your street has flooded in past storms, because past flooding is the single best predictor of future flooding, better than any forecast. And treat official evacuation advisories as instructions rather than suggestions. Japan's warning system is one of the best on Earth, and it is calibrated by people who've watched this happen many times. If you're on Guam, Rota, Tinian, or Saipan, your risk isn't finished. Your risk is the rain arriving behind the storm and the slopes that are already full. And if you're in Taiwan, Eastern China, or Korea, your job this week is simply to keep checking. Not to panic and not to relax, because the honest answer right now is that the forecast for your region doesn't exist yet with any confidence. It will exist within about 2 or 3 days, once the ridge sorts itself out. Here's the specific thing to watch, and it's the cleanest signal in this whole story. Between now and roughly the 24th, watch whether the eye holds. If that 23-mile eye stays clean and open on satellite, Sodle is riding the aggressive forecast and the top of the intensity range is live. If the eye clouds over, gets ragged, or a second ring of thunderstorms appears wrapping around the first, a process that briefly strangles the inner core, you'll be watching the storm peak early and start its slide. Then, on the 26th, watch the Okinawa passage. Not for the drama of the landfall itself, but because whatever Sodle's center does in those hours sets up the answer to the three-country question. The storm's exit angle off the Ryukyus is the tell. We'll be tracking this one straight through the peak, the Okinawa approach, and whichever door it walks through afterward. Hit subscribe and turn on the bell if you want the next reading in this story the moment it comes in, because between now and the 26th, this storm still has room to climb. Out there tonight, over an empty stretch of the Western Pacific, that eye is still open, the water underneath it is still 88 degrees, and nothing is pushing back on it yet.